Okay, so in this video we are going to be completing the square. Essentially what that means, with some questions where we can't factorize properly, but we need to get in a state where I can find out things like the turning point, we'll take expressions like this and put it in a form like this one here. And the whole point of completing the square is that I can kind of see I've got a squared bracket, but we need to make a sort of a correction to sort of finish it off and make it accurate. So I've got two methods. This first method is called equating the coefficients. Now this one can be initially a little bit confusing to get your head around. However, it has much more benefits for taking your maths journey onwards onto higher and such things. And essentially when you start seeing more and more complex versions of these completing the square questions, you can use this exact method that you've learned for Nat 5 into the next one, whereas the issue with the second method I will be showing, you'll have to relearn a whole new method in order to make it work. So let's just jump straight into using this method now. So this first one, we're being told express x squared plus 4x plus 7 in the form of x plus a all squared plus b. So the first thing I'm going to do is I'm going to expand. So that's step one. I'm going to expand and simplify that x plus a squared plus b. So remember, when I've got that bracket with the squared on the outside, that means I've got two of the same bracket. So I need to break apart that first bracket. And that plus b kind of sits on the end. Expand it out, so I've got x squared plus ax plus a squared plus b. And then I want to collect my like terms. So my only like term is this ax plus ax. I've got two of them, so I can just simply say plus 2ax. So that is that bracket all expanded and simplified. Next thing I want to do, so step 2, and this is the clue in the name, I equate my coefficients. So what do I mean by the equate the coefficients? Well, remember a coefficient, that is the value that's in front of your x squareds, your x, and even this bit on the end where I don't have an x. So my first coefficient would be if I had a number there, which in this case is just 1. My next coefficient is this plus 2a. And then my last coefficient is this plus a squared plus b. And these are all going to relate to our original equation. So what I'm actually going to do, I'm going to line them up so I have that x squared plus 2ax plus a squared plus b. And underneath I'm going to just write out that x squared plus 4x plus 7. And we can quite happily see that our x squareds are fine, I don't have to worry about them. And here, where I've got this plus 2a, that is going to be related to this plus 4. And here where I have this plus a squared plus b, that's going to be related to that plus 7. So we are going to make them equal to each other. So 2a equals 4. And that a squared plus b is going to equal that 7. Now that a squared plus b equals 7, I don't know what a is currently, I don't know what b is currently, so I can't do anything with it. But that 2a equals 4, using my knowledge of solving equations, if I just divide by 2, I can isolate the a on its own to give me a equals 2. And so I now have a value for a. And I'm going to take that value and I'm going to put it into that a squared plus b. So that's going to be the same as 2 squared plus b equals 7. And 2 squared is 4. And then same idea, I can now quite easily isolate that b. If I take away the 4 on both sides, I end up with b equals 3. So if I look at my end goal of that x plus a squared plus b, I now know the value of the a and the b, where a is 2 and that b is 3. And so that is my final answer for that question. So let's take a look at another one then. So here I've got express y equals x squared minus 6x plus 20 in the form y equals x minus p squared plus q. Here I've got a little added bit of this y equals, and essentially I can just kind of ignore it, but just make sure I remember to put it back in my final answer at the very end. The rest of it is still going to be the exact same. So I want to expand out that x minus p squared plus q. So that means I've got x minus p plus q. So x minus p, and put the second bracket in the slots next to it. So that's going to be the same as x squared minus px, then that double negative with those minuses makes a positive p squared plus q. And then collecting my like terms together, I've got 2 minus px is, so I'm just going to write that as minus 2px plus p squared plus q. So then I want to equate my coefficients. So the first one, I've got this minus 2p, and that's going to relate to this minus 6 here. So I'm going to have minus 2p equals minus 6. And then I've got this p squared, well, that plus p squared plus q equals that positive 20. So p squared plus q equals 20. So that minus 2p equals minus 6. Well, first I am just going to get rid of the minuses on both sides. And then I'm going to divide by that 2 to give me p equals 3. Then I want to substitute that into my p squared plus q. So it's going to be 3 squared plus q equals 20. So that's going to be 9 plus q equals 20. Take away the 9 on both sides. And it's going to leave me with q equals 11. So going back to my formula of y equals x minus p squared plus q, I'm going to have y equals x. Now, the key thing here is I know what p is. I'm told in that bit above that it's minus, so I'm going to keep that minus in. Substituting that value for p gives me 3 squared plus 11. And there's my final answer for that. Let me know if you have any issues, and good luck with the work.